Hi everyone, welcome to our JC1 H1 Mathematics. We are currently in tutorial 7, right? And we are going to look at the idea of definite integrals. Okay, so this is a video to cover what we couldn't cover in tutorial. Okay, we'll be covering questions 8, 9, and 10. Okay, now if you notice, right, for this definite integral, the idea of definite integral is like this. If we integrate fx to an expression like this, so the definite integral is the integral with limits from a to b. So this means that when we integrate, right, we'll be integrating from this to this fx over here, but we are going to sub in b first and then we sub in a to the expression. So it will be subbing in the b, take this value minus of the value after subbing in a. Okay, so this is what we're going to do. Okay, so starting with part A, now we're going to integrate from -2 to 0 of half x squared plus 5 dx. Okay, so first let us integrate this expression. So this is a power function. We'll get something like half x. Okay, so half times x to the power of 3 over 3 plus 5x. Okay, so this one over here would be integrating from -2 to 0. So this is a power function, power plus 1 over the new power. So let us tidy up a little bit. So over here, I get 1 over 6x cubed plus 5x from -2 to 0. Okay, so the next thing that we will need to do, right, is to sub in one by one. So technically speaking, right, we need to sub in the 0 first. Okay, subbing in the 0 first, and then we sub in the -2. So we'll get something like subbing in 0 for the first and the second term will give us 0 plus 0. Okay, then in the second one, we have to subtract off the one subbing in -2 and -2. Okay, so we will have, when we sub in -2, right, we will have something like 4 over 3 plus 10. Okay, then all together, okay, so but what I usually do, right, is I would normally use my calculator. Okay, and I will look at this expression over here. Okay, and I will key in, I will store the value first. Okay, so let me clear. Okay, so I will store the value into this expression. So keying in keying in 1 over 6. Okay, then move to the right, x cubed, okay, plus 5x, right? Hopefully you can see this. So I press the enter first. Now it will give me some random value, right? Now I won't panic first. I will need to put 0 store into x, enter. Then I will need to go back up to the expression earlier, copy down this earlier expression, and it will give me the value of 0, right? So this one, the first bracket is actually 0. Okay, then the second bracket, right, I will need to store the value of -2. Okay, putting the value of -2, store into x. Can you see this? Then it will give me -2, right? Then go back up to my history, enter. Enter again. So this will give me negative, okay, minus a -34 over 3. Okay, so it will be the first number minus the second number lah. Okay, so altogether this is 34 over 3, or you can write this as 11 1 over 3. Okay, so this is it for part A. Okay, so part B. Now part B, right, we have these brackets over here which is extremely annoying. So what we need to do in order to integrate, right, is we cannot integrate brackets. We have to expand and integrate. So when we expand, let's expand slowly. Now I'm going to expand these two first because this is a plus b, a minus b. So I will expand these two first, which will make my life easier. So a square plus, a square minus b square, like that. Okay, then next I will do the rainbow method of expanding. Okay, so I'll expand these two first, right, to get this. Then I will do this expansion like that. Okay, so what I have there would be x cubed minus x minus 2x squared plus 2 dx. So now let me rearrange, right, for aesthetic purposes, let me rearrange from the highest power to the lowest power. Okay, something like that. Then now let's integrate. Okay, integrating this, power plus 1 over the new power, power plus 1 over the new power, power plus 1 over new power, plus power plus 1 over new power. Okay, so integrating from negative 1 to 2. Now, so obviously this is very long, so let me key in. Now, I'm going to store 2. Store into this x, enter. Then what I will do is key in one by one. So alpha f1 to key in our fraction. So I will have x power 4 over 4 plus minus oops, 1 x power 4 over 4. Okay, it will be minus fraction 2x power 3 whole thing divided by 3, right? And minus another next fraction x power 2 over 2. Okay, then press right, plus 2x. Okay, enter. First value 2 over 3. Second value, I will put negative 1 store into the x. Quickly go up, back to our history, copy, enter. Second value minus negative 19 over 12. Okay. Now then the next thing that we need to do is we will need to take 2 over 3 minus 19 over 12. Okay, enter. I will get 2.25, or I can rewrite this. Okay, so rewriting this one into a fraction, which is number 4, I think. Is it? Yeah. Okay, so this will give me 9 over 4 as the final answer. Okay, moving on to part C. Okay, so over here, right, I'm going to integrate 1 to 4 of 3x squared plus 2 root x over x squared dx. Now, this square root x over here, let me rewrite this into x power half so that I can simplify easier. Okay, so now when we have this fraction, right, where the numerator on top has more terms than the one below, we can actually divide. Or maybe the one below has only one term. So we can just divide and separate the fraction. So we can arrange like this. So 3x squared over x squared would be just 3. Okay, 2x half over x squared would be just 2x to the power of negative 3 over 2 using our law of indices. Okay, so with this, let us integrate. Integrating 3, we'll get 3x power plus 1 over new power plus 2x power plus 1 over the new power, like this. Okay, what do we do next? We have 3x. Okay, now keep change flip, so minus 4. Okay, and then x power negative half is 4 over root x, like that. Okay, and 1 and 4. Okay, so making use of our calculator, first I will store the value of 4 into x. Okay, now next I will have 3x minus 4 divided by the square root of x, like that. Okay, so the first value is 10. Okay, next one, storing the value of 1 into x. go back history to bring down this, equal -1. So 10 minus -1, answer is 11. Okay, for part C. Okay, so let's observe question 9, part A, right? Over here, we're integrating 1 over 3x. So how do we do this? Now, notice that 1 over 3 is a constant, right? This 1 over 3 is a constant over here. So what do we do? I will pull out the 1 over 3 so that I can see what I'm integrating directly. If you can see, then you just integrate directly. If not, just pull out constants, revealing the bare functions, okay? So over here, what I'll need to do is keeping the 1 over 3 there. How do I integrate 1 over x? So this one over here, I will need to, integrating 1 over x will give me ln x, like this. Okay, so and then integrating from 1 to 2. So what do I do first is to sub in the 2 first. So this would be ln 2. Then sub in ln 1. So I need to minus ln 1. Now, however, for ln 1, this is 0. So over here, I will just have 1 over 3 ln 2. Just like that. Okay? So this is for part A. Part B, we are going to integrate from 1 to 2 of 1 minus 1 over 2x dx. Okay? So in the same way, okay, what I'll do is I will need to separate this half from the 1 over x first, revealing the bare function, revealing the function that I need to integrate. Okay, so first one over here, integrating 1, I will get x, in then minus the constant multiple of half, integrating this 1 over x, I will have ln x. Okay, then integrate from 1 to 2. Okay, next I will substitute in 2. Okay, so I have 2 minus half ln 2. Then substituting in 1, I have 1 minus half ln 1. Okay, now ln 1 over here will be 0. Then I will simplify this to just 1 minus half ln 2. Okay, so this is for parts A and B. Okay, moving on to part C. Now, part C over here, right, this is actually 3, 1 minus x power -1, right? The power over there is -1. Or, if you notice the denominator, right, here the power is just 1. Okay? So, what can we do? We will need to integrate to ln as discussed earlier. Okay, so it's mainly this and this, right? As discussed earlier in the earlier questions, we will just integrate this to ln. Okay, so over here, what can we do? Bring the this would be just I will bring the 3 out, okay, so that I know what am I going to integrate over here. Okay, so I have 3. Now then it will be ln 1 minus x, but on top of that, because of the reverse chain rule, I need to divide by -1. Okay, -1 and 0. So bringing the -1 out, so I'll have something like a -3 of ln 1 minus x, 0 and -1. Okay, so let me sub in the 0 first. So this would be ln 1, then minus ln of 2, 1 minus -1. Then over here, ln 1 over here is 0. So this turns out to be a value of 3 ln 2. Okay, now part D. Over here, we have integrating 0 to 1 of 1 plus 2x power -1 dx. Now, take note over here, this power again is -1. Okay, this power over here is -1. So, must take note, it will be integrated to ln. So, over here, this would be ln of 1 plus 2x. But because of the reverse chain rule, I need to divide by 2. So we have this whole function over here integrating from 0 to 1, right? Integrated from 0 to 1. Okay, so let's put in these values, or maybe I bring the half out first. Okay, now let me sub in the values now. So subbing in the top value 1 first. So I have a ln 5. Then putting in the 0, I have a ln 1 minus ln 1, like that. Okay, then once again, ln 1 is 0. Hopefully you get the message already. Then it will be just half ln 5 as our final answer for part D. Oh, sorry, it's minus. Eh, wait. Sorry, this is actually ln, not ln 5, ln 3. Okay, ln 3, ln 3. Okay, sorry, my bad. Okay, yeah. Okay, so here is all that we need to do for question 9. So continuing on to question 10. Now, you see, we are evaluating this, right? Leaving our answers in terms of E. So this means that we want exact values. Okay. Now, unlike the previous question also, right? Like, let's say if you just evaluate and it's only a 1 mark question, then we can make use of the calculator over here. Okay. Now, however, if they have more marks, let's say 2 or 3 marks, then they are asking us to evaluate in exact terms lah. Okay, or they will specify for us to evaluate in exact terms. Okay, otherwise, if it's just a 1 mark question, we can just make use of our beloved GC for the answer. Okay, so moving back to question 10. Okay, so because I don't think we need the calculator, right? Okay, so let's do this. Now part A. So let's integrate from 0 to 1 e to x dx. So integrating this is just e to x. Integrating e is just e, but because of the reverse chain rule, instead of times 2x, I need to divide 2x. Differentiate, you times, integrate, you divide. Okay, evaluate from 0 to 1. Now I'm going to bring the half out to make it easier for me to sub in. Okay, so subbing in, right, would be now over here e2 2 times 1, so it will be e2 minus e0, like this. Okay, putting in the values for 1 and 2. Now e power 0 is actually 1, so what do I have at the end would be half e square minus 1, and I'll just leave the answer like that. It's okay to leave the answer like that. It's already exact value. Okay, next for part B. Now here I'm going to integrate now e power negative x over 2 dx, but let me rewrite this in an easy to see form. So this will be e power negative half x dx. Okay, so it's just about to writing it, right, to separate the fraction out with the x. Okay, so with this, very easy already. So we have e to the power of negative half x. Because of reverse chain rule, I will need to divide by negative half. Okay, so next step, change, flip, and bring the constant multiple out. So I have negative 2 on the outside. Okay, now we sub. So negative 2. Okay, we have e to the power of negative 1 minus e0, like that. Okay, e0 over here. Okay, e0 over here is just 1. Okay, so what we have as our answer is just negative 2 of e power negative 1 minus 1. Okay, and we can keep this like that. Or let's say if we really want, we can just expand this to negative 2 e power negative 1 plus 2. Okay, so this will be answer for part B. Okay, last but not least, for part C, integrating from 0 to 1/3 of 3 minus. Okay, I'm going to rewrite this as half e power negative 3x. That. Okay, writing it easier for us to, in a form easier for us to integrate. Okay, so integrating 3 power plus 1 over new power, so become 3x. Okay, then minus, now half, okay, e power negative 3x, but because of the reverse chain rule, divide by negative 3, like this. Okay, then evaluate from 0 to 1/3. Okay, so at this stage, let us rewrite this in an easy form to deal with first. So over here, 3x is just 3x, but I will need to combine all of this as one constant multiple. So this one over here will be plus 1 over 6. Okay, e power negative 3x, right? Maybe I will put like this 1 over 6 of e power 3x. Okay, so let me sub in now. Okay, so first bracket, so I have 3 times 1/3 is just 1 plus 1 over 6e. Okay, so subbing in the 1/3 to 3x, right, will give me 1. Okay, then I will sub 0 and I will sub 0 to get 6e0. Okay, but take note our e0 over here is 1. Okay, so over here, now 1 minus 1 over 6, so 5 over 6 plus 1 over 6e would be our final answer for part C. Okay, so that's it for this particular video where we went through questions 8, 9, 10, covering the concept of definite integral. Okay, so from 1 to 7, we have already looked at how do we integrate the various functions. So what are the techniques? In 8, 9, 10 is a matter of just doing the definite integral, integrating with limits. Okay, so that's all for this video. All right, so hope you had a good learning time and hope you are able to integrate more confidently now. Okay, so that's all. Bye bye.